In this video, we're going over final exam review topic for Math 161. We're expanding log. We're writing the logarithm as a sum or difference of logarithms. Simplify each term as much as possible. Oh, it's a little mess over here. All right, so let me take a look. So we have log base 3 of 83 x cubed, whoopsies, x cubed, and in a parenthesis, z squared plus 5 raised to the 5th power. So guys, I count three things on the numerator. 81, x cubed, z squared plus 5 raised to the 5th power. So those are three factors that are multiplying on the numerator. Now, the denominator is a little simple. We just have 1/4 root of y plus 7. So I'm going to separate these out, okay? Now notice the red, orange, and green, the things on the numerator, they're all on top of the fraction, okay? So those will have positive signs, okay? But the one in the blue, okay, that I highlighted in blue, this in the denominator, the 4th root of y plus 7, that's in the denominator, right? So when we write it out, this term will have a minus sign. So watch this for me. So the first term I'm going to write is log base 3 of 81. Next, I'm going to write plus log base 3 of x to the 3rd power. Next, the plus sign, do log base 3 of z squared plus 5 to the 5th power. Now notice all those three terms that I wrote are positive, right? Because they're all on the numerator. Now we're going to the bottom of the fraction. We're going to need a minus sign now. Okay, so look, we're going to do minus log base 3 of 4th root of y plus 7. All right. Now, they did say simplify each term as much as possible. And when you are expanding log, we want to bring down the exponents to the numerator in front as the coefficient. So, well, let's look at one term at a time though. The very first one, in fact, we can simplify that actually. So log base 3 of 81. Now, what's that going to be? I think that's 4. Okay, let's see though. Well, you guys do know about the change of base formula that you can use to evaluate this. So that will be a good opportunity for me to review that real quick. So I'll show you. So I'm going to go to Desmos Scientific Calculator, and I'll show you how you can type in log base 3 of 81 on the calculator. I can do natural log of 81 divided by natural log of 3. What's that? 4, right? Now, why is it 4? Because look, you guys, if you do 3 to the 4th power, you do get 81. And logs are all about asking what is the exponent that will take this base to become this log argument. And we know 3 to the 4th power is 81. So when you use the change of base formula to evaluate this log base 3 of 81, and it came out 4, that makes sense, okay? So the red part turns out to be just 4. Moving on to the orange, the second term. Bring that exponent of 3 in front and write it as 3 times log base 3 of x. Same thing. Bring that exponent of 5 down to the front and write it as plus 5 times log base 3 of z squared plus 5 without exponent. Now, the blue needs a little work though, okay? I'm done with the first 3 terms, okay? They're going to wait here, okay? Now, look at I just want you to focus on this blue term for me, okay? There is a way for me to rewrite this 4th root, okay? And that's going to be very useful. That's going to be important in the calculus class, okay? When you guys move up to calculus, you will need to know how to rewrite these radical expressions into rational form. And when you're using this thing called power rule later. So what you want to do is write down y plus 7 in a parenthesis and say that's getting raised to the 1/4 power. That's how you go from a radical form to a rational exponent form, okay? Now look, if this was a fifth power, I would have put 1 over 5, okay? This was a fourth root, so I put 1 over fourth power, okay? Now same thing will happen. This exponent of 1 over 4 will come down to the front right after the minus sign, but before that log base 3. So here's the final answer, okay? After all those terms, I am now going to write minus 1/4 log base 3 of y plus 7. Now you may wonder, why do we have to expand it out so that it looks much more, well, longer than what we started with? Well, when you are, well, this is actually to get you ready for calculus class. When you are in calculus class, we may have to work with each of these terms. And if you can separate them out, you can deal with smaller pieces one at a time instead of, trying to break or trying to do something with this very composite, big chunk of a term. So breaking down a complicated looking log term into smaller pieces will make calculus work a lot easier. So that's why in pre-calc we want you to practice expanding these log expressions, okay?